Hi friends, in this video we are going to discuss about the concept of capacitance calculations. So basically we are using two different types of connections. So those are series connection and parallel connection. Just see here. So we are using series connection and parallel connection. So before we are going to enter into this particular getting the value of equivalent capacitance by using series combination and parallel combination. So the main difference between getting the equivalent resistance and getting the equivalent inductance and getting the equivalent capacitance is the procedure we are using to get the equivalent resistance and also equivalent inductance is same. But coming to getting the equivalent capacitance is completely opposite to the resistance and inductance. It means, for example, if two resistors or two inductors are connected in series, then to find the equivalent resistance and inductance, how we can calculate? By adding all the values. Okay, now by directly adding the values of resistances and the value of inductances, you will get the value of equivalent resistance and inductance for series connection. But in case of capacitance, whatever the procedure we are using, the series connection of resistances and series connection of inductances, that procedure we are using when two capacitors are connected in parallel. Okay, it means that R1 and R2, these two are the resistors and connected in series, for example. Then the procedure we are using to get this particular equivalent resistance, how? Directly by adding these two values R1 and R2, you are getting the equivalent resistance. But in case of capacitance, we need to consider this procedure whenever the two capacitors are connected in parallel. Okay, now it means the procedure we are using in case of resistance and inductance for the series, that procedure is applicable in case of capacitance for parallel connection. Okay, so that is a main important thing. So just see here. So we are going to discuss about the first 2 points, that is, just see. So first, this one is a series connection and this one is the parallel connection. Okay, so first we are going to discuss about the parallel series connection. Okay, so this one is a series connection. Now, for example, here the capacitance C1 and C2, these two capacitances are there. Okay, so C1 consisting of two terminals, one is, so just see here, one is A and another one is A dash. And coming to the second capacitor, that is, one terminal is B and another terminal is B dash. It means that for each capacitor having two terminals, so here A dash are the two terminals of capacitor C1 and B dash are the two terminals of capacitor C2. Okay, now coming to the series connection. So here the series connection, just see here, just see here. So this one is the series connection. It means that what? Whenever these two capacitors are connected like this, so this particular connection we are calling a series connection. Okay, just see here. So A dash are the terminals of C1 capacitor, B dash are the terminals of C2 capacitor. Here, whenever the left terminal, that is A1 terminal of capacitor C1 is directly connected to B terminal of capacitor C2, then this type of connection we are calling as series connection. So whenever we have series connection in case of capacitances, then we need to use or we need to follow the procedure, whatever the procedure we are used in the parallel connection of resistance and parallel connection of inductance. Okay, so that is the reason why here the thing is, whenever the two capacitors are connected in series, we need to consider the addition of reciprocals of those particular capacitors. Okay, so that is the reason why here we have taken, so reciprocal of equivalent capacitance is equal to the sum of reciprocals of C1 and C2. Okay, so that is what? 1 by C1 plus 1 by C2. Now you know the value of, for example, you know the value of C1 and C2, then substitute like this, you will get the value of C equivalent. Okay, just see here. So here we are doing, so 1 by C equivalent is equal to So 1 by C1 plus 1 by C2. So here by simplifying, take LCM and simplify. So here you are getting, so C2 plus C1 divided by C1 into C2. So 1 by C equivalent is equal to C2 plus C1 divided by C1 into C2. Now this is the reciprocal of C equivalent, but we required what? We required only the equivalent capacitance. So that is the reason why C equivalent is equal to C1 into C2 divided by C1 plus C2. Okay. So this is the formula we are using to calculate the equivalent capacitance when two capacitors are connected in series. Okay. Now this is about what? Series connection. Now coming to the parallel connection. So here the parallel connection, just see here. So whenever the A terminal and B terminal of two individual capacitors are connected directly like this, and A dash and B dash of two individual capacitors are connected like this, then this particular type of connection we are calling as parallel connection. Okay, so whenever two capacitors are connected in parallel, then to find the equivalent capacitance, then directly we can add the two values. Okay, directly we can add the two values like this. Just see here. So directly we can add the two values like this. It will gives the value of what? Equivalent capacitance of the parallel combination of C1 and C2. Okay. So like this we can easily find the series and parallel connection of the capacitances. Okay. Please remember, when capacitor C1 and C2 are connected in parallel in series, then we need to consider the reciprocal of addition of or sum of reciprocals of individual capacitors and get the value. And when the two capacitors are connected in parallel, we can directly add the two values of capacitances. Okay, so based on these particular two calculations, so we are going to solve individual problems. Okay, now see here, this is the first example. Okay, so this one is a first example. Calculate equivalent capacitance for following figure. Okay, calculate equivalent capacitance for following figure. Now we have a series combination here. Just see here, we have a series combination of two capacitors like this. So C1, C2 are connected in series means to get the C equivalent or equivalent capacitance, we need to consider the sum of the reciprocals of capacitances. Okay, so for that, so reciprocal of C equivalent is equal to reciprocal of C1 plus reciprocal of C2. Okay, now 1 by C equivalent is equal to, taking LCM and simplifying, so you will get 20 plus 10 divided by 20 into 10. Okay, 20 plus 10 divided by 10 plus 10 into 20. So by simplifying, you will get the value of this particular 1 by C equivalent or reciprocal of equivalent capacitance is equal to, so 3 divided by 20. So we required only the value of C equivalent. We don't require the value of reciprocal of C equivalent. So for that, by simplifying, so 1 by C equivalent is equal to 3 divided by 20. Then, so C equivalent is equal to 20 divided by 3. So finally by simplifying, you will get the value of C equivalent is equal to 6.6666 farads. Okay. So like this we can find whenever we have the two capacitors are connected in series. Okay, now coming to the example number 2. Okay, just see here the example number 2. Calculate equivalent capacitance for the following figure. Okay, so calculate equivalent capacitance for following figure. Here just observe here, the given circuit is parallel combination of three capacitors. Okay, C1, C2, C3 are connected in parallel, but we know that whenever capacitors are connected in parallel, to find the equivalent capacitance, we can directly add the individual values. Okay, we can directly add the individual values. So that is the reason why, so above circuit is parallel combination of C1, C2, C3. So that to find the equivalent capacitance, we can directly add values of capacitances. So C equivalent is equal to C1 plus C2 plus C3. Now we know the value of C1, C2, C3 which are given in the problem, so that you can directly place all the value of capacitances like this. Then by simplifying, finally you will get the C equivalent is equal to 100 farads. Okay, so like this we can find series and parallel combination of capacitances, and these calculations are very important. So while you are going for the analysis of electric circuits. Okay, so thank you so much for watching, and please do subscribe my channel for more updates. Thank you.